Okay, let's dive into exercise 11.3. So here I've got the solution for it. Notice we've created a DMA FIFO. So just quickly look at it. We've got the name here. It's going to be a target to host DMA. So we're transferring data from the FPGA to the host. And here we've defined the FPGA buffer size. Notice that the data type here we've defined to be an I16. So let's take a look at the FPGA VI first. And this is where we're going to write data. And in this example, we're going to talk about how overflow is handled. But before we get to that, let's talk about the basic operation of the FPGA VI. So notice we've got a loop timer here to do the loop rate. And then here we've got an FPGA I/O node. And notice over here, if there is no overflow, by default, overflow is false. Okay. So as long as there's no overflow, that means it's safe to write data to the DMA FIFO. Okay. So in this case, we're acquiring some data from the FPGA I/O node, and we're writing it into the DMA FIFO so we can transfer that buffer data all the way up to the host. Okay? And here we see that the timed out here is monitoring whether we have an overflow, right? So if this node times out, that means the FIFO is full, and therefore we have some lost data now, and that's going to output a true here and set our overflow indicator to true. Okay? Because it's an indicator here, that means our host VI is going to be able to check that indicator and see whether an overflow condition happened and take action based on that. Okay. So now let's go back up to the host. So in our project, let's go ahead and open the Windows host. And let's look at the block diagram here. Okay, so let's look up here at the top. Notice that we're just opening up the FPGA VI reference. We're configuring the host buffer size, which is right over here. And here we're also taking a look at the DMA FIFO. Okay, so let me scroll over real quick so we can get all this on the screen. So really what we're doing here is we are going over here and we're checking, okay, well, we're waiting for 10 elements to be available, right? So here we're not reading any actual elements here. See, that's 0. We're just checking how many elements are in the FIFO. Now, if there's less than 10 elements available, then we're just not going to do anything, and we're just going to wait 1 millisecond. Okay? But as soon as there's 10 or more elements in the FIFO, then this will go to true, and we will read exactly 10 elements from the FIFO. Okay, and then we're going to output it out on this data indicator. Okay, and for now, let's assume everything's running fine, and we're reading the overflow, right? So this is coming from our FPGA VI, and we're reading that indicator. If overflow is false, then everything's good, and we're just not going to do anything, and we're just going to keep executing this while loop. Okay? Now let's take a look at what happens if there is an overflow. So I'm going to jump back here to our FPGA VI. So now we're on our FPGA again, and let's say this times out and outputs a true. That means overflow is going to be true, and now we're going to enter the true case of this case structure. So let's see how this application decides to handle overflow. So notice that if we go to our true case, we're going to check, okay, is the DMA cleared control false or true? So at the very beginning of our application, this is a control on our FPGA VI. By default, this is going to be false. Okay, so the DMA cleared equals false right now. So that means we're going to set this shift register to true. That means on the next iteration of this while loop, the true is going to flow out of here, and then we're going to execute the true case over here. So notice now, when this is running, if there's an overflow, it's not going to do anything. So as long as this is true, that means we have an overflow condition, and we're not going to write anything more to our DMA FIFO. Okay, so we've stopped writing to our DMA FIFO. And notice over here, what we're going to do is we're just going to keep executing the logic in this while loop that's shown right now until the host is setting the DMA cleared control to true. Okay, so we're waiting for the host to know that there's an overflow, and then guarantee to us and tell us that the DMA is cleared and we can start over. Okay, so let's look back at the host VI. So on the host VI, let's say the overflow, we're checking that and it's actually true right now. So how do we handle that? So if we go to true, let's look at what happens. Okay, so in this case, if overflow occurs in the FPGA VI, we're going to flush the DMA FIFO. So now we're going to take a look at this. We know that on our FPGA VI, we've already stopped writing. So if you look down here, notice that we're no longer writing anything to our DMA FIFO. So what we can do now on the host is we can read how many elements are remaining in that FIFO. I'm going to go ahead and find that out, and then I'm going to read all the remaining elements and just output it here to our flush data. Okay? At this point, we've flushed our DMA FIFO, so that means there's nothing in it. So we're good to go. We're going to say, okay, now that that's done, we're going to put true to DMA cleared. And if we go down here, once DMA cleared is true on our FPGA VI, notice that we're going to say, okay, well, let's set our DMA cleared control back to false, okay? And then we're also going to set the overflow shift register back to false. So in that case, we're going to put false here, and then on the next iteration of our while loop, a false is going to come out of here, which means that this case structure is going to do false, and we're going to start writing data again. And then because this is false, now we're just going to do nothing here again, and we're back to our regular normal operation. Okay, and if we look up here, the overflow is going to no longer be true, so this is going to go back to false, and on the host we're going to go back to our regular operation as well. Okay, so this is just one example of how you can handle overflow with DMA FIFOs. You can choose whatever method or think of whatever method is more appropriate for your application. For example, maybe if an overflow happens, you might just want to shut down the application right away, and maybe just output the flush data and maybe log that to a file on your host computer. So really, it's up to you how you want to handle it. This is just one example to maybe inspire you.